So this is our last section, 5.7. We're going to talk about inequalities in two triangles. Yes? No, not a lot. All right, so the first thing we're going to talk about, our book calls it the Hinge Theorem. And you may also hear it called the side angle side inequality. And we call it the hinge theorem because it's kind of the idea of a hinge makes sense with what we talked about. All right, so we're going to say in two triangles. So we're comparing two triangles. In two triangles, if two sides of the triangle are congruent, but the angle between them is not. So we have two triangles. We have two sides, two pairs of sides that are congruent, but the angles between those sides, that's what we call it the side angle side. We have a side and angle on the side. The angles between those sides are not congruent. The largest side is across from the largest angle. So let's draw a picture, and it should make sense then why we're calling this the hinge theorem. So here's two triangles. And what we're saying here is that this side and this side are congruent, and that side are congruent. Not necessarily, but we have two sides, two pairs of sides that are congruent, and the angle between them not congruent. I'm going to call this triangle ABC, and this triangle X, Y, Z. So what we're saying is if the measure of angle A is greater than the measure of angle B, measure of angle X, then this side, BC, is greater than YZ. That's all this is telling us. These two sides are congruent. This angle is bigger, so that side has to be bigger. This angle is smaller, so that side has to be smaller. And that's why we call it the hinge theorem. It's like a door on a hinge. The door and the door frame are the same size, but if the door is open further, then we can get more stuff through the door. If the door is closed more, then it's not open very much, and we can't fit much through there. That's why we call it the hinge theorem. You can also think of the hands of a clock. They're always the same length, but if the angle between them is bigger, their tips are further apart. The angle between them is smaller, their tips are closer together. So that's all this hinge theorem is telling us. If we open this up more, this distance is bigger than that distance. All right, questions? Folks, electronics, they need to be away, please. All right, let's look at a couple of examples. What else can we figure out? So here's a picture. So here are two triangles, triangle ABC and triangle XYZ. So from this information that we have, what else can we figure out? What does this little square on this angle mean? The right angle, it's 90 degrees. Well, these two sides are congruent to these two sides. This angle is 98, this angle is 90. So what does that tell us? They're not congruent. It tells us something about a side of a triangle too. XZ has to be longer. XZ has to be greater than AB. Because this angle is bigger, that side has to be bigger. This door is open further. The hinge is open further. Questions? Questions there? And that's all the hinge theorem is telling us. This angle is bigger, this side has to be bigger. The hands of a clock, where are they further apart? At 9 or 2, the tips of the hands of the clock. 9. What angle do they make? What angle the hands of the clock make at 9 o'clock? 90-degree angle. And at 2 o'clock, so if we're on our clock here, there's 9 o'clock. And at 2 o'clock, or like so, this angle is smaller, so the distance between the tips of the hands of the clock have to be smaller, so they're further apart at 9 o'clock. That's all. That's really all this hinge theorem is telling us. This angle is bigger, so this side has to be bigger. All right, questions? Questions on that one? Hopefully this makes sense. You can visualize this in your heads. It's not complicated. All right, the converse of the hinge theorem also works. And sometimes you'll hear this called the side-side-side inequality. The converse tells us, rather than figuring out something about the sides of the triangles, it lets us figure out something about the angles of the triangles. So, in two triangles, yes? In two triangles, if two pairs of sides are congruent, but the third sides are not, So we have two sides that are congruent, the third side's not. What the converse tells us is the bigger angle is across from the longer side. So instead of figuring out something about the sides of our triangles, this lets us figure out something about the angles. Our picture would look almost exactly the same. There's one triangle. There's the other triangle. We're saying that those two sides are congruent. And there are our triangles ABC and XYZ. If this side is bigger, if BC is larger than YZ, then measure of angle A is bigger than measure of angle X. This side is bigger, so that angle has to be bigger. This side is smaller, so that angle has to be smaller. That's all we're saying. And the interesting thing here is this: we would prove this using a proof by contradiction. So if we assume that these angles were congruent, so that would be our temporary assumption. Assume the opposite of what we wanted to prove. Assume that they're congruent. Well, that would mean the triangles would be congruent by side angle side. And so the corresponding parts would have to be congruent, which is a contradiction, because we know that they're not. So that would show that those angles can't be congruent. So we use a proof by contradiction. All right, questions on our theorem? Okay, let's look at how we are going to use it. So here's my triangle, my two triangles. And this question asks us, what are the possible values for x? So kind of like our opener, slightly different though. So here we have two sides of our triangles, congruent. We have the included angle, and this side is 11 and this side is 7. So based on that information, which angle has to be the biggest? Which is going to be bigger, 88 or 4x minus 8? Which one is it? 88, right? Because this side is bigger, so this angle has to be bigger. So this has to be the biggest angle. So there's one part of our possible value for x. 88 has to be greater than 4x minus 8. This side is bigger, so that angle has to be the bigger angle. Well, we can solve this. I add 8 to both sides, so it gets 96 greater than 4x, divided by 4, and I get 24 is greater than x. So there's one part of my range of values there. Before we do the other part, let me ask you guys, when we're working with inequalities, do you remember when we have to be careful of turning the arrow around when we're solving inequalities? When you multiply or divide by a negative, you have to turn the arrow around. So just a quick reminder there. We haven't come up with that so far, but if that does happen, then you have to turn the arrow. All right, so there's one part of our range of values. How do we get the other part? We need x between something and something else. Anybody have an idea of what that might be? What does this angle have to be bigger than in order to even have a triangle? 0, right? If that angle were 0, those two sides would be right down against each other and we wouldn't have a triangle. So this angle 4x minus 8 has to be bigger than 0. If it equals 0, then we don't have a triangle at all. I add 8 to both sides. I get 4x equals 8. Divide by 4, and x is greater than 2. So this tells me that x is between 2 and 24. Or the other way we write that is 2 is less than x, less than 24. So x is between 2 and 24. That makes sure that this angle is the biggest angle. All right, questions there? All right, let's take a look at how we would use these ideas to do an easy proof, and then we'll be done. So here's our picture. And we're given that the measure of angle RUS equals 100 degrees. And we know that SU equals UT. Those are congruent. Why don't I do this? Segment SU congruent to segment UT. And we want to prove that RT is less than RS. All right, I'm not going to rewrite our given. We already have those, our givens. So when we have two triangles set up like this, what's the first thing? What's a really easy thing to figure out? Well, SU and UT, we have those. Those are given. But we do know that.
RU.
And what's true about RU, Carolyn? We know RU. We have that. It shares that side. So Iris said it shares that side. We know it's congruent to itself. What's our reason? Reflexive. All right, so let's mark what we know. This, we figured out that's congruent to itself. Let's mark this angle RUS is 100 degrees. That's from that. All right, what else can we figure out now? RUT, would it be 100 degrees? 90? What do these two together make? 180. So what is RUT? 80. So I'm going to write that down. Measure of angle RUT is 80 degrees. What would my reason be for that? What do we call that kind of angle, that pair of angles? A linear pair. They're supplementary. They're a linear pair. All right, so since this angle is bigger, this angle is smaller, now what can we say? Which of these sides is going to be bigger or smaller? RS is going to be greater than RT. Isn't that what we were trying to prove? Yes? We could say the converse of the Hinge theorem. We could say the side inequality. Or we could just say because measure of angle RUT is less than the measure of angle RUS. Because that angle is smaller, that side has to be smaller. So some kind of explanation that says the angle is smaller, so the side has to be smaller. And that's all we need. All right, questions? Okay. There's homework.